Everyone, welcome to another Geek Tips video. My name is Tim Paul from Toolpath, and I thought I would do what Toolpath we call Toolpath Chronicles. So what I'm going to do, since my accident 4 or 5 months ago, or I broke my neck, I've been doing a lot of just sitting around banging on Toolpath, creating tickets for bugs, tickets for improvements, and just basically making these little videos for the development team and the rest of Toolpath, showing things that kind of need to be changed, things I'd like to be changed. To be honest, also kind of celebrating, what we've done well. So I thought, why don't I do just machine this thing last night? I thought, why don't I do this more publicly? So I'll show the things that we still need to improve on. I'll show what I think we did a really good job on. But really, there's also some kind of tips and tricks to pick up along the way with both Toolpath, Fusion, maybe even some machining stuff. If all goes well, we'll see how my editing skills are. If all goes well, I'll edit in some machining footage if I think it's relevant. So what I did on the Fusion side is I have this material that I have left over from another job. So it's 4-inch round stock by 1.5 inch. I knew it would fit this part pretty nicely. This is real similar to a real part I made quite a few years ago. So what I've been doing with these Toolpath Chronicles videos is kind of thinking back through stuff that I've done in the past, and highlight some kind of more challenging stuff. So if we do, there's nothing really challenging about this part, except that there is quite a few mouse clicks. There's this kind of undercut feature that we'll need to use a keyseat cutter. There's an undercut feature over here. There's kind of some tricky walls. If we look here, you've got to machine down to here while also avoiding this with a specific tool radius. So nothing really hard, just a lot of mouse clicks. That's a good trick, by the way. Go to inspect, do a section view, and then you can turn that on and off. That allows you to see where the toolpaths are inside parts that are kind of hard to see them. So let's just get over to Toolpath as quick as possible. So from here, I already did a couple setups, right? Let's make sure, see where we're at here. So I want to machine everything from this orientation first. I might as well talk through this. So at home, I don't duplicate program numbers. So I kind of catalog everything in a spreadsheet. I've seen some pretty big accidents on machines happen from, everybody's doing 1001 or whatever. So I just keep it in a spreadsheet and kind of keep a tally, move on. Maybe I'll go back someday and delete a bunch, but I've worked at places where I made 3,000 programs in a year or two, and there's still plenty of numbers left. So my first one's going to be C3 first op, G56, and 20019. So let's start off 20019, C3 first op, and then if I remember right, G56 will be my first. G56 will be my first program. I have this little cheat sheet thing over here, so number 3 is G56. So if I go here and do number 3, that'll output to G56. My stock, I modeled up a solid, and my work coordinate system is going to be the bottom center of the stock for the first op. For the second operation, this is going to be 20020, and it's going to be C3 second op. And then if I come back here, G57, that's number 4. G57, that's all I should really need, right? G57, so number 4. So now that I have that done, I'm going to save it. And then I'm going to send this to Toolpath. So you got to get the Toolpath add-in There's lots of, if you just go to our website, or Google it even, you'll see the instructions on how to do that. So send to Toolpath. I'm going to include these setups because I'm actually hit cancel. But I'm going to include the setups because I actually want to check this setup. I originally was going to do this at the bottom center of this. But to be honest, I'm going to hold this thing in parallels or on a step jaw. And I want to use the edge of this. So there's a couple ways we can do it. I can come here and do model box point and pick this point right here, or actually right here. And that'll work. That should work pretty good. If my intent, which is actually what I really want to do, is be on this surface, because then I can probe the surface of the parallels, right? So the easiest way to do that is just make a sketch. And what's the easiest way? I'll do this, and I'll make a constraint from here to here, from here to here. I'll make this tangent to here. And this side honestly doesn't matter, but I'll go from here to here, right? So now what I can do is I can create a sketch point. Let's just put it off here so I can make dang sure I get the right point. So that point right there is going to be my, I'll even just call this G57. So that point right there is going to be my work coordinate system in the manufacturing side, right? Because I'm setting it on parallels on this surface here, and I want to be able to probe my spot, right? So I'm going to probe the parallel there. On the Z, I'll probe the hard fixed side on the Z, on the Y, and then what I do is I run a parallel across my two jaws to kind of put it up against this. I'm only making one of these things, so I'm just looking to do it as quick as possible. And then I'll probe the jaw right here after I set it up with the parallel. So let's just edit that. I'll do from a selection point of this. X, Z, and Y are good. Hit OK. Go to model. I can hide that now. Okay, so now I'm going to do this. I kind of like to name these ready-for-Toolpath. Okay, so now when I come over here and send it to Toolpath, I can either do model body and Toolpath will create its own setups, or I can say, hey, these are the two setups I want to do. And since I did that work of like micromanaging where the WCS is and all that, might as well use it, right? So there's a couple, if I go back here, there's 4, these are 1032 tapped holes. To be honest, I use form tapping, and Toolpath right now isn't set up to do drill and for form taps. So I expect to just kind of delete those. So we can handle that a couple different ways. What we need to do is go to the setups tab in a minute and then change those holes to 1032 and then let it regenerate. So once this turns black, I can go do that. Right now it's just processing the geometry. It'd be nice. I think we have plans to make it where you can kind of do that before it starts running it through the AI game. Yeah, so right now I can go to setups, and on this 4 holes here, I can do 1032. Like I said, I already expect it to, I regenerated there. I already expect it to not get the results I want because I use a 1032 form tap. I don't have it in my tool library. I don't have the right drill, to be honest, for a cut tap. And you can see here, I have by default my kind of home tool library that I use on my VF2SS in the garage. So this will take probably 2 or 3 minutes to calculate. It's running through it pretty quick, but we'll do some movie magic. I ran this thing already. last night. So let's just grab that file, which is right here, and take a look at it real quick. So we're not going to spend a ton of time going through Toolpath. It's pretty straightforward though. It's recommending this drill for these holes, but I don't want to use that, so I'm just going to ignore it. And whatever tools it thinks it's going to machine these with, it doesn't think it could, get past that shoulder there. So we'll ignore that, and that's where that 1% comes from. But if we go to setups, that's the first setup, that's the second setup. Pretty straightforward. If we go to tools, this is the list of tools we're going to use. Let's see details about those. We can click there. We can see the different, this is basically the only thing that's getting faced with that tool. Go to strategy. If we click on the setups up here, we can see everything that's getting, machined in that setup. If I click on tool, I can see some tool information, go down, and this is basically supposed to be a one-to-one. If you go from here to here to here, you'll see a one-to-one about what's getting machined along the way. Estimate. But I want to get you over to Toolpath as fast as possible. So, whoops. Well, here we go. This already processed. So let's just go from here, hit export. We're going to copy that key, and then we're going to get over to Fusion. And if our intention is to import all that into the current document, which is what I would do if I was, doing this for real, I would just do that, and it'll populate these setups. But because I want to use this later, I use this to kind of bug check. So I leave these alone, and so every time we come up with a new version, I just come back and send this to Toolpath and check out stuff. I'm gonna do an import into a new document. If you want a layer of separation, that's not a bad way to do it. So now it's just bringing it in. There's the stock, and it's going to go through and populate all the operations. Now there's a Fusion bug that I've been experiencing since the last update, where when I click on these toolpaths, I won't see them until I go out of manufacturing and then back into manufacturing. Now, when I click on a toolpath, I'll see it. So here's what I do, and this is my intention for you, is I'm just going to go down the list. If I like it, I'll move on. If I want to micromanage something, I'll talk to you about what I want to micromanage. If I see something silly, I'll talk to you about what I see silly, why it's silly, move on from there. This looks good to me, so I'll move on. This is kind of silly, so let's do a inspect section view. We'll click here and we'll flip it so we can see it from over here, right? So this is a little silly. We did rough all the way down there. We don't need to be doing both of these, right? And it's actually doing them two different times. So for now, instead of deleting, I'm just going to suppress toolpaths I don't want to use, so we can kind of go back and check anything out that we want to check out. Now, how do I want to handle this? Let's go in and check this out. So on we're constraining this with a selection and a diameter range. So what happened if I did this? I click on that. And that is the same as that. I know that it's the same as that. If we did whole bottom, it's got a bull nose, so let's leave that. Then we just want to change the top to selection. We could do this. I'm kind of happier with that, and it's still a roughing operation. And I know this tool hauls butt when it roughs. So I'm going to change that, and then it'll generate this. So just to be clear, I suppressed one, and I just want us to do both. It sees it as two separate features, so it's trying to machine it as two separate features. Not a big deal. I'm pretty happy with this. This is a rest machine because it was using this bullnose to do all the adaptive. It found a little bit of rest areas to come in a machine. This is smart enough to do, do this bottom one, and then it does the top one. So it doesn't. I know that it does them both at the same time. So I'm gonna suppress that top one. This is something we're kind of working on. We haven't made it a huge priority, but it's already roughed in. What it's really trying to do is just face this guy. If I was in micromanage mode, I would just do a 2D contour around there. But I'm in get this thing on the machine as fast as possible mode. So I'm going to pick there, and move on. I'm just going to let it do that thing. Save a couple seconds in cutting air. This is going to machine this and this at the same time. I'm happy with that. This is machining all this flat area on there. I'm happy with that. This looks like it's machining this contour here. I'm happy with that. That's machining that. I'm happy with that. This is something I don't love, but I don't care enough to micromanage it. We do open contours with flat, just like we saw up here. And then we do the 2D contour, right? I like this. Some people want to know why flat just doesn't have machine finish passes or whatever. But you don't have a wear compensation, so you can't control your size with that. So I think only savages do that. But for now, like this could be machined with a 2D contour with 0 stock to leave with wear compensation and machine the wall and the floor at the same time. We haven't split them up yet. That's something we'll work on here probably fairly soon. But for now, there's nothing wrong with that. The way it does it is this 2D contour comes in, machines the wall, and it has like I think a 1 thou axial stock to leave, and then it comes in and does the floor with a 0 axial stock to leave and like a 1 thou. I mean, we can check it here. I think it's a 1 or 5 thou on the wall. So you could save a couple seconds there if that's what you're going for. Let's regenerate this while we talk about the next toolpath. Oh, okay. So what's happening here? If I hover over this, it says contour is not machined because the given lead parameters would cause blah, blah, blah. If I double click on this, you can usually see what's happening when you go to the geometry tab. It's trying to machine down to the bottom of those because I didn't have the right tool to make that feature. The good news is I don't actually want to machine it that way, so I'm going to suppress it. And then I will regenerate this. And you get a pretty good toolpath there. So this is a rest machine. It's picking out some rest material from the 1/2" tool in these corners, and it's machining these, which I like. It's doing a finish on these pockets here, which I'm happy with. And the cool thing with this is you don't have to come into every toolpath and micromanage it because these presets are my presets. You know, my tool library is configured to have a different preset for this is aluminum wrought, so that's your typical bar stock wall finish. So it's machining the wall finish, so I don't have to come in and micromanage every little parameter. I can just look at it. Yep, I like it, move on. Same here. Yep, I like it, move on. I like it, move on. Okay, so this is cool. We're doing a pretty good job of these chamfers here. Good job on the chamfer there. This keyseat cutter, if I go to measure and I measure from here to here, that's it's 100 thou difference between the inner and outer. And my little $200 Harvey keyseat cutter is not going to be happy cutting that at 96 inches a minute. So what I'm going to do is, I already have a ticket for this. We're not respecting the step over on keyseat cutter, so remember that for now. But we're going to make sure we have this keyseat cutter preset selected. We'll go to the passes tab. I'm going to turn on roughing passes. And then that's going to make it do maximum step over 25 thou. It's 100 thou. 100 divided by 25 is 4. And then the other thing I want to do is come up here and change the step over to like 10 thou. So it'll do a 10 thou finish pass, right? And if I want, I can do the roughing feed times 0.5 or something. So it does this last pass. It does at half the it's ripping around pretty fast for those. So we'll hit OK there. This is the cool thing. A lot of people struggle with getting this $200 keyseat cutter to get the right steps in the axial cuts. So Toolpath does a really good job at that. We just need to start respecting the step over passes, and we already have a ticket that should get done fairly soon, I imagine. Okay, so then we have this tapping operation. To be honest, I micromanage the crap out of my tapping. I like to drill, chamfer, and tap a very specific way. So I'm not even gonna look at it. I'm just gonna suppress it for now. There'll be a day that I'm happy with what Toolpath is putting out, but I'm not ready for that yet. Mostly because it's not using the drills that I need to do my form tapping with. So what do we have left to do? We have some chamfers to do, like these. What I want to do also is chamfer this and chamfer this. So I'll use the under-chamfer. I know my machine already has a thread mill, single point thread mill. And I want to use it for that because I just want to knock the sharp edge off of those. I do have a side chamfer tool. It doesn't have a very long stick out. I need to get a bigger one or find where I put my bigger one. But I'm just going to break the edge with a thread mill, and I'll show you how to do that. So we have some of these chamfers that we want to dial in, like do these blind chamfers. This guy, we're going to leave that one, right? Because we'll have to under-chamfer that later, because when we're down here, we'll screw ourselves up if we do that one now. Okay, so let's start with the 1032 tapped holes. So I already have a template set up. So we're going to create from template, and I have this 1032. It's going to drill, chamfer, and tap. So those use my favorite tools. And then now all I need to do is a geometry selection, right? So I can come grab this. I already have these select same diameter and auto merge hole segments. That way it doesn't wrap it into that huge chamfer. Now I have all these pre-done, right? So it'll drill past far enough to get a really nice, just the right depth past to get a full thread on my probably 2.5 lead tap, right? So then on my chamfers, I save these with geometry, so I need to clear those. I need to turn off my section view. And then I just need to pick the bottom edge of these, and that'll give me a nice chamfer. Okay. And then on my tap, I just need to select this, and that'll be legit. So what I want to do is this part has these bosses. I want to make sure that I'm not drilling past them. So I'm going to turn on the section view and go to this tap view or drill view, and it does look like we're over drilling that, and I don't like that. So this is a fake part, so we're just going to come in here and now we're going to actually turn that back on. We're going to come down. It's 90. So this is perfect, like technically it's perfect, right? But we're going to come off, I don't know, let's say 0.075. I'm going to do a 75 thou higher, or actually negative. Yeah, so we'll shorten it up by 75 thou, and we'll do that there. And then I'm also going to do it here. Yeah, so if you saw, that was almost breaking through at the bottom there. And then I'll do another negative 75 thou. And I'm typing inch because the kernel is in metric, and sometimes that would have done not good. Okay, so now we can see both of these are well above the bottom there. If this was a rigid rule, if I had X amount of threads, I would get in and see what I needed to do. Maybe I needed to thread mill this thing. Maybe I needed to get a tap with a OLT or something, like a one lead thread tap, right? So that I can hit it without breaking through the bottom. But this is just a fake part to kind of to test the software, make sure we're doing everything, and share some stuff with you guys. Okay, now I need to do some chamfering. Let's do the blind chamfers first. So I'm going to do a 2D chamfer. I've got other videos on how to do this as well. I'm looking for my 3/16 chamfer mill. I'll pick here. I'm tempted to pick this, but remember we didn't machine down far enough to do that. That's really all I need to do there. And there is some magic here. I already have my presets. No, I already have my defaults saved. So typically I want a 10 thou chamfer. It's kind of a funky tip offset, and I'll explain that in a second. And then this has a 2 thou chamfer clearance. That means I'm going to miss this boss here by 2 thou. So let's go simulate this thing. And then I'll show you kind of the goodness of it, and then we'll go understand it. So if I rotate this thing around and I zoom in, you can see I've got a tiny little clearance from that wall. Now it's a 2 thou clearance because that's the clearance that we just saw, right? And I'm way up on the chamfer mill, which means I can get really close to this edge. The farther down the chamfer mill, the farther away from that edge you have to be. So this has, I bet you it's a 10 thou clearance. Might be a 5 thou clearance, but I'll show you where I control that. So if you're taking notes, I did do a Geek tips about chamfering or whatever. You can go watch that, but I'll show this here. A long time ago, I came up with this expression. If you're taking notes, it takes the tool diameter divided by 2, take away the tool tip diameter divided by 2. So what it does, it gets the chamfering area. How much can you chamfer with? And then it takes away the chamfer width, and then it takes away 5 thousandths of an inch. And so that the upper edge of the chamfer mill was 5 thou above that surface. If we wanted to be more, we would change that number there. But if you watch this tip offset, if I change this chamfer width to 5 thou, the tip offset changes. So it keeps you way up on that chamfer mill. If I change this to 20, it changes. So make it back to 10. I'm pretty proud of that. I came up with that expression, I don't know, 8 years ago, 9 years ago. I think Fusion should use it as a default, but write that down. And once you have all that in there, you can just come over here to these 3 dots and save as user default. Save as user default. I also modify these settings to where I have a perpendicular lead in with no radius, 90 degrees, and a fairly short one. So it just has a nice clean little come straight in. If it's arced, you'll have some blending problems. So enough about that. Let's turn on the section view, and then I have a create from template. I shared this, and if you go look at one of the Geek tips about some chick one lock jaws, I go into more detail there. But I have this template. I use my chamfer mill to do a under chamfer. right? So, and then might as well just use a template and do these tool 30 for side chamfering. So that put these two down here. I'll clear this selection, pick on this, hit OK. That's what's so nice about templates, is once you get all these little dorky details dialed in, like here, you can just go chamfer, just go grab the geometry and it's good. Assuming my templates are good, which hopefully I made them good before I saved them. Now if we look at this view here, I've got a nice little chamfer to break that edge there. Now, you know, let's say the print just says break all edges. It doesn't say it can't be a 30-degree chamfer or 60-degree chamfer, however you want to look at it. So we're breaking the edge there, and then we're also, I didn't mean to do that, here. And we're also breaking the edge here. Now, if you go try to do this, you might get an alarm that this tool is not valid for this type of operation. It actually should be, but go watch that Chick One Lock vise video. I went into more details there. I keep a thread mill as a 4mm and a thread mill because it won't let you, because it won't let you do that with a thread mill. It's kind of silly on Fusion's part. So that's a lot of talking. I knocked that out pretty quick last night when I was doing it myself. Some people would like to maybe chamfer this from under chamfer, but I would leave that. I just assume I get this accurate on the backside. So maybe I'll put in a little video clip of some side chamfering with a thread mill. I think I might have got that last night. Nothing real interesting here. We suppressed a couple. I hope you can see how much faster that is than all the picks and clicks of containing toolpaths the way you want. You know, we're driving more and more to complete, programming on these prismatic parts. But at the very least, we'd love to save a ton of mouse clicks for you. All right, so with that, I'm going to save it, and I'll say, oh, I'm not going to save this. I'll use this as a throwaway. I would normally save it and version it as like first op simulated. I would normally come here, go to simulate, look for anything red, don't see anything. Maybe I would simulate it. And then what I do by habit is after I simulate it, I protect it. I think I missed that, didn't I? I protect it. And so what that tells me is that I've simulated it and it's ready to run. Now I move over to the next operation. For now, let's turn off that the section analysis. I think we have more significant changes to make to this side. Let's just regenerate these. And here's something on the first side, hopefully I'll remember to share some video footage of it in the machine. But on the first side, I was holding on to it with these these Mighty Bite Versa grips, I think they're called. Yeah, Versa grips. And they have about 100 thou. They're holding on to about 100 thou material. So in my head, I was like, I just need to clear those by 125 thou. There's a good workflow to incorporate your work holding. Prismatic parts, I very rarely do, to be honest, especially if I'm just trying to do quick and dirty one part here and there. But what I do know, and so this is a workflow that I do fairly often, I'm holding on to this here and on a 200 thou step jaw. Not 2-inch, but 200 thou. So I just do an offset plane, so I have a visual reference. People are going to hate me for that, for not modeling up my vices. I love me some vice modeling and work holding modeling. I just very rarely do it with just a 2.5 axis, 3 axis parts. So now when I come to the manufacturing side, you'll see kind of why I do that. because of this, because I can quickly see like, oh, that would be a problem. I'm holding on to these flats right here on a 200 thou step jaw, and that is going to be a problem, this toolpath right there. So let's just, do we want to quickly look down through this? We'll just fix the problems as we see them, right? So first thing I'm going to do, this is a totally valid facing operation. If I felt like I had a really good hold on this part, I would let that sucker rip, because it's ripping pretty good, 320 inches a minute. That's coming from my presets. I'd be pretty stoked with that. If I was more stoked with how I'm holding on to the part, I'm holding on to just the tiny little areas with 200 thou and aluminum step jaw. So what I'm going to do is I'm going to change this sucker here to be 25 thou steps. I know it takes a while, but I'm making one of these things. And to be honest, I'm also going to do a stock to leave of 20 thou, because I don't want to do a finishing step. Yeah, actually, so many choices to make. Yeah, I don't want to do a finishing step because I like to change my RPM. In a finishing step, you can change the feed, you just can't change the RPM. So I'm going to do 20 thou stock to leave there. I'll do a maximum step down of 25 thou, and that'll get me this here. Just a bunch of steps, which is totally fine. And then what I do is I duplicate this. I'll grab my preset for finishing. I'll get rid of multiple steps and stock to leave. And then that's my finish pass. So boom, boom. Regenerate this normally, but I already know I want to change the height, right? So why don't I edit this? Go to geometry and edit it to do a silhouette and cut inside the silhouette. See what that gets us. So I don't want to give away too much, but we're working on including, we already have some kind of pre-release stuff for work holding, so you'll be able to kind of incorporate work holding workflows. But for now, I just kind of grind through it, and simple parts like this. My job is to get them done as fast as possible, right? Hopefully that's your job as well. So generate these. Fine with that. Fine with, that's a collision right there, right? So really our intent is to keep it inside again. So we'll do silhouette inside. Oh, what I should have done is on this one, I should have done height to this lip here. Go to selection. I'll do this minus like 100 thou. And that'll get rid of like the big top hat type thing that we're trying to get rid of, right? So actually no, I'm bouncing around. I'll do none here, and I'll just contain that to yeah, I'm sorry. So on this toolpath, I did none, so I can get rid of that top hat, right? But it's still above this where my soft jaws are. I like that. I'm bouncing around. I think I'm still getting over, breaking my neck and hitting my head and all that stuff. So sorry for bouncing around. Trying to make these as raw as possible while sharing some good information. So let's just keep going down through this. I'm going to regenerate these guys. So we have adaptive. I like that a lot. We have a flat. I like that a lot. Another flat I like. I really like this. It's getting all the flat surfaces. I don't love this. It's technically fine. But why would I not just go all the way around and hit both sides? So that's what I'm going to do. I'm going to hit edit, clear the selection. I'm going to click here, and I'm happy with that. Yep. So that makes me pretty happy. I keep having to do these because these are rest machine operations. So there. I'm pretty happy with that. I like that. We might be able to combine those. I don't care enough to take the time to do it, to be honest. Oh, this is rest machining, so it's getting out there. I love it. Here's something you're going to see with Toolpath for a while. We're working on the background to be a little smarter, to be honest. But we do a rest machining here. You can see it doesn't quite connect here, right? So if I turn on in-process stock, the thing is it gets rid of that material there. So that's okay. But right now we're leaning on the side of conservative. So we come in with these pocket clearings and say, hey, if you find extra material, go clear it out for us, please. So sometimes you'll see it like just do some pocket clearing here or maybe over here. And then sometimes you'll get these empty toolpaths. Just take a look at them. Sometimes I'll open them up. I'll go to the geometry tab. And that's what it's doing. It's saying, hey, inside these areas, if you could find some little leftover stuff, go machine it. What does it say here? So same thing. So I'm gonna control select those and suppress them. Normally I would just delete them, to be honest. But for now, I just want to make sure they're still there. I'm happy with this. I'm happy with that. Arguably, those might be combined. Yeah, those could probably be combined. You don't need a flat in it because the one contour does both. So what I would do there is just suppress this. Double click on this and then get rid of the stock to leave. We're leaving a 1 axial stock to leave. So that will do both the floor and the wall at the same time. I like this a lot. I like that a lot. I like that a lot. You know what? For now, I'm gonna get rid of this annoying plane. That is pretty annoying. So I can see better. If I see anything that's dipping out here, I'll turn it back on and we can go double check it. Regenerate this. Now last night, I think I went from the model to the machine, and I was not rushing. I had a lot more time in setting up the GoPro than I had in doing all this stuff. I think I had 10 or 15 minutes and just really looking at everything, kind of optimizing everything. So, okay, this is probably a rest machine that's unneeded, really. Yeah, it's just a rest machine that Toolpath is playing conservative. Basically, go do the rest of the machining if we missed anything. So I'll suppress that. Okay. Like the contour there. Sometimes I'll do this. I'll go to these contours. I'll zoom in, and it's going nice distance below that feature. We nail that stuff pretty good. This is a tricky one here because this and the bottom of this are the same, but this area right here overlaps. So this does end up making basically a tiny little razor blade sharp area there. And I just came in and deburred it with my thread mill. Side chamfer mill or dovetail would work too, but I don't have those in the machine. So this does a good job there, but remember, we already took care of this way up there. So let's just suppress that. And now we get into some chamfers. Chamfer's good. Chamfer's good. Let's turn this analysis on. Chamfer. I love it. And Toolpath does a really good job. I'll brag a little bit. I mean, it's pretty basic, but it's the kind of stuff that, like, this is what AI is really good at, is your cutting conditions way up here are way better than way down here, because the lower you get down here, the lower your surface speed is, right? So the higher you get up your chamfer mills, the better. We do a really good job of kind of optimizing that. So we chamfered that and that, and we already chamfered this and this, so we're good there. So I can turn off my section analysis because I'm not inside the part anymore. And then so we chamfer those two bosses, chamfer that one and that one. A little funky that it broke them all up, but I don't care enough to change it, to be honest. We did the undercutting there. And now we need to do it here. And this is not an insignificant depth of cut. This is 100 thou again. So I would break my $200 key seat cutter there. So we're going to do the same thing we did on the first operation. We're going to come to roughing passes. We're going to do, okay, so this is going full Monty. So we need to switch to this other preset. It's the same preset, but when Toolpath grabs it, it kind of locks it in. So we're going to switch to this. And when we do that, now it respects our side, our maximum step over from the preset at the tool library level. We know 100 thou width of cut divided by 4, divided by 25 thou is 4 passes. And then I just want a 10 thou finish pass. And I might as well slow that sucker down on the finish pass. So times 0.5. Now by default, I repeat finish pass, which is just a spring pass, but I don't need that here, so I'll get rid of that, save a few seconds. I like it. I like it a lot. Okay, so that's a done part. If you're savage and want to go deburr all this stuff by hand. So if you have a few minutes, I like to make complete parts. Mr. D taught me back in high school, if any of your parts could cut him, you got an F, not a lower grade, you got an F. So he taught me well. So how do I do that? We already did it on the first side, but stick with me. So we're going to go to 2D chamfer. This is kind of neat. I like this select from document. I do really like that. So we're going to use this 3/16 tool 43. That's my kind of longer reach. Narrow this thing up a bit. And what I'm going to do is, I don't think I have enough tip clearance to get around here, but I do here and here and here and here. Oh, not there. I'm getting a little jerky since my accident, unfortunately. Sucks. Here and here and here and here and here. So that leaves this, which I have a tiny little chamfer mill that will sneak in on that. Okay. Because all my defaults are set for 2D chamfer, for lead-ins and all that stuff, this works like magic. So there will be a day, I'd like to think fairly soon, that we'll do this just automatically from Toolpath. But for now, if that's what I got to do to program a part, I feel like I'm doing pretty dang good. So looks like we're missing a bit here. A little bit of a bummer. So let's, that means that the tool's too big to pick up that edge here, right? So if I pick this edge and clear that out, I'll pick that up. I'll pick this edge up with my smaller chamfer mill. Everything else looks good to me. This guy is a situation, right? My tiny chamfer mill won't reach in there. You know what we'll do is I'll show you something when we're done. But I'm happy with that. Now what I'll do is I'll grab another 2D chamfer. I don't think that's in my document. Yeah, it's not in my document. So let me shrink up my my library so you can see it. Okay, so I have this library. It's my combined library that has everything. My chamfer mills, and I got this cute little guy right here, the 16 thou aluminum chamfer. And then now what I have to do is pick this. Oh, that bigger guy would have gotten these fine, but now I'm past it, so I don't want to think about it. And then I also want to grab this guy. So that looks glorious, and then because all my defaults are set well, we're just dialed in here. We're 2 thou clearance, 10 thou clearance, and we're good. Now, what do we want to do down here? So this is, I mean, you could do several things, but that's tricky. It's only 40 thou off this floor. I'm going to use the 3D deburr operation, and I'm going to come down to my combined library, do a ball mill. I don't think I have like a long reach little end mill, right? I think I need to reach down in there pretty good. So I'll just grab this 1/4 inch, and it'll do most of it, but it won't get super close up to that edge. I think deburr might only be in the manufacturing extension. I personally would pay for it for that and like steep and shallow. But I'm going to do machining boundary none, edge to deburr. You can leave it automatic and it'll go do a bunch of stuff. But I just want to do this one selection here. 10 thou. There we go. So it does this nice, chamfer, and it misses some of this, but you can come in and knock that off with a deburr knife or Scotch-Brite or something. This is a very complete part. The video always takes a long time to kind of talk through, but from here, actually I'll just walk you through it. So I'll do a simulation. I don't usually watch the simulation. I'm definitely not going to subject you to watching it. I look down through here. I don't see any red. There's some red down here, which is this chamfer mill, because it's not colliding. It just thinks it's got a problem down there. And then I usually just leave it. I'm not suggesting that you leave it. I typically, when I do a stock simulation, I turn the stock on. I go to tail for that. And then I turn on stop on collisions. That way it stops whenever there's a collision. I usually speed it way up because I don't really care to. We'll just watch it cut the stock. It's showing these chamfers as gouges because technically that's true, right? So we're going to exit the simulation. Oh, and then we still need to under chamfer this with that thread mill. So on the bottom of this, we're gonna edit. Oh, that's interesting. So we just need to come in, click this again, go to open chain, and then go to the last bit of that open chain. Oh, and this will be interesting. I covered this in that Chick One Lock soft jaws that I was making, but I'll show you how I work through this. One or more contours are missing. Selections to machine. Oh, got it. Okay. This is lingering. I have a bad habit of saving. Fusion makes this suck, to be honest. I have a bad habit of saving with geometry selected, saving templates where Fusion shouldn't leave that geometry selected. I guess there's some outlying workflows that might make sense of that. Let me show you how I decide how much to come off of this edge so I'm not gouging that. Simulate. Okay, I'm going to go to all toolpaths, no stock. Click on that red intersection. You can see it's just plowing this here. Now what I do is we have to do a tangential extension of negative tangential extension, so trim the toolpath of something like this, right? I like to be greedy, so I'd probably do something like this. But how do we know how much that is? In the olden days, you would trim, simulate trim. What I do, hopefully, this move is in like an X or Y motion or direction. And so if I click on this point right here, go to info, you can see the X is changing as I slide through this, right? So what I do is I click on there, and that's 3.352. Get my phone out. If I was at my desk, I would have, sorry, I'm on the recliner. I haven't been able to work at my desk for a while. So 3.352, and then what I do is I left-click hold out in this white space, and I just drag this to a point that it's not colliding. Like that. So 3.352. So 3.352. Take away 3.44. That's 88 thou. So now all we have to do is edit this, double click that, and I can go negative 88 thou. Luckily that's the same geometry on both sides. So now that toolpath shortened up. Simulate it. Zoom in, and we got a little tiny bit of clearance. I would probably get a little greedier than that, but I shouldn't. And then we get just a beautiful little under-chamfer there. This deburr, it might be a little much, to be honest. I might come in here and mess around with changing my radial stock to leave to maybe 21, or just barely takes the edge off. Anyways, this is done and ready to run. The last thing I'm going to drop on you is, because of the way I have this thing set up, and because I didn't care too much, I didn't have to hold a super tight tolerance on the outside of this. My chamfers, all my features might get kind of wonky, because I set it up from that edge there based on a parallel against the other jaw. What I would actually do is I would, what would I do? I would want to do a probing operation of this feature right here before I started setting the geometry for everything, right? That's what I did last night, and everything came out really nice. So if I go down through this, like we start getting into some finishing operations here, and I don't love that. We don't get to the finish bore this until down here. So what I would do, these are all roughing, right? So between the 65 and the 21, what I'm going to do is I'm going to add a boring operation with tool 21, bore rough, to this here. What I'm going to do is I'm going to leave a significant stock to leave. I'm going to do like a 20 thou stock to leave. Because I want to leave plenty of material in case this thing is out of location. And last night I watched the numbers. It moved like 2 thou. So my initial location was off probably about 2 thou. This tool can ramp more aggressively than that. So do 5 degrees on that. And then boring doesn't have an axial stock to leave, so I'm going to do a 5 thou stock to leave here. I'm confident that I have the Z set right, because that was a hard thing I could probe. So I'm just going to give myself 5 thou there. So now I have to drag this away up here. So I'm going to make that the first tool 21 operation there. Now what I want to do is under that, no, this actually needs to get moved up there. So under that, I want to make a probe, a WCS probe, and I'm going to shift it. That way, if that hole is off by some small amount, my whole G57 will shift before I start setting final geometry in. So from there, I'll go to inspection, probe WCS. Actually, what do we have here? No tool selected or in there. And then geometry, I'll just pick this surface here. I don't need that much of an approach. Over travel's fine. The key here is that I want to do an override of the WCS. And actually, let's see what's happening here. Oh, I brought this into a new document, right? So this needs to be 20020 C3. So because I'm doing some movie magic, right? I would have normally, if I was you, I would have brought this back into the existing document and all that would have been good. But I brought it into a new document because I kind of wanted to keep a separation because I use this for testing. Sorry about that. Okay, so I'm going to take this, I'm going to drag this guy up after this 21. So we're going to rough, bore, and then probe. Now this probe looks like it's way off, right? But it's a 6mm probe, so what happens if I click on this? It is way off. That's not good. That sucks. We want that to be right there. Yeah, right there. That's interesting. I don't know what I did. Last night it was good. Simulate. Yeah, maybe check it. But from here, that's what you want, is to be probing that. I checked that last night. It was fine. But so now regenerate the. Oh, we have to. Sorry, I'm jumping around a bunch. On the actions, you want to make this 4. We're not going to make a big deep dive on this, but what's going to happen is you're going to use offset 4 to drive your tool, your probe around. And offset 4 is G57 in this case. And then the WCS to be updated is also 4. So if it comes down and the theoretical perfect distance from this WCS to the center of this hole is 1 inch and 1 inch, and it's 1 inch and a thou and 1 inch and 2 thou, or some small shift difference, after it does a probe, this operation, it'll shift your WCS. If you watch your, in this case, G57, in the middle of the probe cycle, those numbers change. Last night, mine changed 2 thou in the X and like half thou or something in the Y. It was pretty small in the Y. But that just proves that my setup was pretty good, but not perfect. So once this regenerates, I would, well, since you're sticking with me, once this regenerates, I would simulate it again. I would lock the operations. And while that's simulating, let me just show you how I do my posting. So I'm going to hit post process. And an NC program pops up. And this sucks because this is my normal drive that's not connected right now. So let's just dump that out to the downloads folder. And this, I would have that changed. But the cool thing here is all these keep my last settings, right? If you don't know about G187 and you run a Haas machine, go YouTube search CJ's video that he did with Haas. It's worth watching. And then you can come over here and see the operations you're gonna post, and I would post that thing out. Now, let's see if we're good here. We're still doing the in-process stock calculation there, but then I would post this thing. Well, let's see what happens if I hit post right now. And then here's what I see. Some people, I open up their NC programs. Yeah, NC valid. It's still calculating stuff. And they've got 50, they've got 50 damn NC programs. So this is what I think you should be doing. Because when you double click on this, your first op will be tied to the first NC program. If you don't want to post everything, because that's what will happen, right? Somebody will run half the program and then they want to just run one. If you just want to post these two, then just deselect them and then post that out again. You'll say, do you want to replace it? Yes, and so on. So with that, I think we're done. I drug that out. I have a hard time lately of keeping things short, but I think there's some good nuggets hiding in there. If you guys want to see anything specific, please share in the comments. I plan on doing more of this kind of complete workflow and sharing some of these Chronicle parts that I've been enjoying working on for our team's internal. So I don't think there's anything we should really hiding. I think this is some good stuff for everybody, or especially people interested in leveraging Toolpath to program more efficiently. All right, everybody, have a good one. Cheers.